This podcast is brought to you by LMU Munich.
Hello. Yeah, my name is Dmitry Trofimov. I work for JetBrains, and you can guess from the name of this talk that I developed PyCharm IDE for 7 years, since May 2010, something like that. And today I'd like to talk about web frameworks and what it is to support them in the IDE. And we'll talk about web frameworks in general. We'll look at some statistics. We'll learn how web frameworks supporting the IDE should look like and how it is implemented in PyCharm under the hood. And also I will show you several obstacles which are on the way of the developers of tools. So Python web frameworks. There are a lot of Python web frameworks, maybe a couple of dozens. Some of them are very popular, some of them aren't, some are new, some are old, and some even have dedicated conferences, some are deprecated. And it's hard to choose when you want to make a website, which one to choose is hard. It depends on the requirements, first of all, and sometimes on your experience. But let's ask ourselves another question, like which Python framework is Pythonic? And do you know the answer? Which is the most Pythonic web framework? Let's try to find out, like, what can help us. Maybe Zen of Python can help us. That is Zen of Python. Everybody read that. Like, it's import this statement. From those 19 statements, which everybody is very well aware of, for me, 2 can help us, like, answering our question. Those 2, like, simple is better than complex. And the second one, there should be one, and preferably only one obvious way to do it. Like let's take Flask, for example. Flask is very lightweight, and it's very simple. It's much simpler than Django. So, like, according to the first statement, it should be considered as a Pythonic web framework. But if you want to use ORM in Flask, what ORM do you choose? Is it SQL Alchemy or Pony ORM? Which admin do you use? There are several options. And it's always so with Flask, so you always have options, plenty of them. And for Django, for example, the obvious way is always the only one. So Django ORM, Django admin, Django forms, and you don't have to choose in the beginning. So according to the second statement, Django is more Pythonic, right? So those 2 statements, they kind of contradict each other. And this contradiction defines the never-ending holy war, full-stack web frameworks versus micro frameworks. And some people prefer the former, others the later. And also we have a pyramid, which claims to be the both at the same time. But we still want to know the answer, which one is more Pythonic. And the answer actually lies in the Python standard library documentation. So section 10.12 of the Python standard library documentation tells us about Python batteries included philosophy. So it says that actually in Python standard library you have, like, everything and even more. And it lists some packages. I actually knew about those packages that they exist, what I learned recently at PyCon US, that Python standard library has a SMTP server inside, like smtpd.py. It is like it's bundled with Python, like, which is kind of strange, but that's Python philosophy. So according to that, Django is a batteries included framework, and therefore it is more Pythonic. Like, do you agree with that? Yeah. So you can agree with that or you cannot, but there are a lot of people in the world, a lot of developers who use different frameworks, and let's try to understand what they think. That's what we often do when we develop PyCharm. We try to understand what other people think. And let's look at the statistics. So according to these statistics, 45% of Python web developers, they agree with the battery included philosophy, and they use Django. Others use Flask, the micro framework, from the opposite end of the spectrum, and it's 29%. And 16% use Tornado, the framework that allows you to process requests asynchronously. And but I have to tell here that those numbers are not mutually exclusive. Some people can use both Tornado and Django, for example, and Tornado and Flask. And other web frameworks, they are like 2-3%, parameter 3, others like 2, 1 something. And there is no Web2Py here. We have support in PyCharm for Web2Py. It's not here. Like Web2Py, do you know, everybody knows about Web2Py framework? Yeah, that's the framework which in 2011 won the title the best open source project, and in 2012 the technology of the year, and now it died. Why? I don't know, but my guess is that it doesn't support Python 3. So actually we live in a great year when if a project doesn't support Python 3, it dies. Like it's 2017 already, and in 2017 we have this picture. According to the usages in PyCharm, Python 3 started to win recently over Python 2. Like it's 52% combined usages of Python 3, which is cool. Congratulations! It's happened eventually this year. Like it's April or March. And then another thing that we can say from these statistics is that Python 3.6 has an awesome adoption, because normally people adopt new versions of Python slowly, but 3.6 is like everybody just took it. Maybe because performance improvements in Python 3.6. If you want to know about that, like listen to some talks of Victor Stina, who made this work in Python 3.6. I can tell about PyCharm that in PyCharm, for example, debugger became 40 times faster in Python 3.6. So if you don't use Python 3.6, please consider switching, unless you use Web2Py, but I guess you don't. Yeah, it's 2017 already, right? And let's move a bit in the past to October 2010. And I don't know, that speech is supposed to represent October 2010. If anybody remembers, did it look like that? I don't know. But in 2010, we had Python 3.2 alpha released and Python 2 6.6 released not long ago, and Django 1.3 was around the corner with class-based views. And JetBrains is releasing PyCharm 1.0. Finally, a powerful Python and Django IDE. Let's look at it closer. You look at this picture, like this funny worm stuck in the P letter on the cloud, and that hides the sun. I don't know what it means, but it was a nice picture. And mighty Python and Django IDE. And it says, like in the blog post, it said like PyCharm 1.0 provides a complete set of tools for Python, Django, and Google App Engine developers. What exactly was the Django support in PyCharm? In the same blog post, there was a comment by some user. He said that like, I tried the PyCharm 1.0 trial and was blown away with the ease of programming Django, so I purchased it right away. The price is minimal when compared to others for sale. I particularly love the ability to click the run icon in the IDE, and it starts the server and run my application. Oh, so nice. How cool is that? Like a button that starts a Django server. Isn't it a decent support of a great framework? Actually, it had much more than that, not only one button that starts your server. Let's talk about that. What makes the good support of web framework in an IDE? The basic level is the efficient code editor, because it's about software development, right? It's about coding, programming, call it how you want. So the code editor should be good, first of all. But that's not the ultimate level. Some tools, they stay on this level, and they were good in that, like Sublime Text, and but they kind of stay on that level. So it's not the IDE approach. IDE approach is to go a bit further, and on top of that level to add a level of code insight. It's when the IDE tries to understand your code and makes interconnections between the different symbols of your code. For example, you can resolve, navigate to imports, to the standard library, to complete the attributes, functions, find usages. In every place, like the idea is like in every place of your code, it's some meaningful symbol, you should be able to go somewhere or find usages of that. And that would be actually enough for pure Python code. But that's not enough for web framework. For web framework, there should be one more level, is understanding framework-specific semantics. For example, in Django, you can have classes which are models, actually, which are not like normal Python classes, which are extend Django model, and they represent like entities in database, and they have special fields. Like an IDE should understand that, which special fields it has, and IDE should understand the configuration of the web framework project. So and more than that, and there is one more thing, is IDE should try to simplify and automate your tedious task, like from the beginning, from the project creation to the deployment to the remote server, and to run tasks and your server to debug things, execute code. And I would like to briefly show how it looks. How many people use PyCharm? Not everybody, but quite. And who do Django, by the way? And Flask? Okay. So it doesn't quite well correspond to our statistics there, but yeah. So yeah, I just show, I don't know whether you know those features. I think if you use PyCharm and it works, yeah, right? So it's actually, I won't show you a lot of things, but it's all stuff you know that you can go, like if you have your Python code, you have auto-completion, post list, you can, no, it stopped the debugger, don't need it here. We can navigate here, we can go to templates, we can complete things here, and we can find like where it was declared. We can find usages, that's post, where it's used, so you are probably pretty well aware of that. And it has a debugger, which I told you about, so you can just start the project, and like, yeah, it's Django girls block taken as an example. And we place breakpoint and see how it works. And we have debugger here, and we can even go to the templates and place breakpoints in templates. And then proceed, we can stop here. And so actually that's what I told about. It's from every place of your code you can navigate to the library or to your declarations. So it's pretty solid support, I would say. Let's talk about how it is implemented under the hood. So it looks like decent, like it's all interconnected, but how it is implemented. The basic concept of all JetBrains IDEs is PSI. It's a so-called program source interface. The core concept, this core idea helps you to have the one uniform interface to look at your code. It is, PSI is a tree. It represents a program syntax tree, but actually it does much more than that. That's a tree that grows from the directories. So it starts growing from directories, and then it goes down, for example, in directories. A directory is a PSI node, is a node in the tree. And when you go down, a file in this directory is also the PSI node. And inside this file you have classes, and all classes are also PSI nodes. And inside class you have methods, they are nodes, and so on. Like every statement is a PSI node, and it goes down to the token. And this tree is so uniformal that it allows you to have interconnection between different languages. So if you have, as I showed you, Python and Django template, so you could navigate from Python to Django template and back. It is possible because those are PSI nodes which have references to each other. They are referenced in one tree, so it works for different languages. And I will explain a bit later how it is built. There are some interesting things, but I want now to say about one more very useful basic concept which is required to build an IDE is you need to have index, because you need to search things, you need to search them fast. And there are two basic indexes. One is word index. So for every word you actually store the file where this word occurs, a list of files. And it allows you to find fast in path and find usages of elements. So for example, how find usage works is it goes to the indexes, looks like this class name in which file it contains, and then it takes those files and look whether those PSI elements point actually to this symbol which you want to find. And a second index which is very important is PSI stub index. That's a compact binary serialization of symbols in a file. It's not possible, when I talked about this huge tree which grows from directories, so in theory this tree exists, but it's never exists on practice, because it's not possible to have all this tree in memory, or it's not possible to have all this tree with parsed tokens for every file. Even on disk it will be very slow. So this tree that it is lazy evaluated, and it actually the files are parsed fully only when they are open. When they are not open, they are parsed only for visible elements. For example, during indexing process, you open a file and you store the name of the classes and the name of the functions to be able to resolve to them, and you don't care about the contents of those methods and classes, about fields, when they are not visible, of course. And that is a PSI stub index. It's also indexing, so it scans the code. And it goes like that. So when you start the IDE, for example, the first time, it goes through all files and projects in libraries of Python interpreter, and it parses them to extract the public declarations and store them in stub indexes. Also, it constructs a word index. When it's done, it's not rebuilt all the time from scratch. It's updated incrementally. And yeah, only elements visible from outside are processed. That's an optimization. And how it's parsed, it's like Lexer, produce stream of tokens, and then there is a parser that builds the syntax tree. And that's not the final tree. Most often, that's when you process data languages, you have Lexer and parse, and that's it, and then you work on the syntax tree. What we have in JetBrains for IDEs is this PSI tree. PSI tree is not syntax tree. It's a bit higher level. It's a tree that built from the syntax tree, and it provides you with higher level functions. For example, syntax tree can be it's just a class, and you can get children of methods and fields. But PSI node, it corresponds to this syntax tree, but it also carries semantics. For example, you can get all the superclasses from it. So there are methods that allows you to, it provides you with a high-level API. And on top of this API, you can build framework-specific support operations. That's only possible because of this a bit higher level PSI tree. And there is one more thing which is very important. It's type inference. So Python dynamic language, but still to provide good code completion and resolve declarations, you need to infer types. And so we do that from many sources. We take return types and store them. We analyze control flow inside the function. We store type information when we do indexing. We grab types from docstrings for type annotations. We have special set of standard library annotations. When they are missing standard library, we have our own annotated types. And for frameworks, we have specific type providers. For example, there are some dynamic methods I will show you later. Dynamic fields in Django models, for example, which are provided with types. So it sounds pretty solid, like the tree, the index, those are very well-known algorithms, so it seems that it should work, right? No problems with that. But actually, there are a lot of problems, and I'll show you some of them. For example, one problem is Python has binary models in standard library. And we need, for every symbol that you import, you need to provide the possibility to resolve to it, where you need to resolve. For example, if it's a scene in a math binary package, it's a binary, you cannot resolve. So what PyCharm does is it generates those stubs, which are called skeletons in this case, because stubs are a different thing in our platform. It generates those skeletons, they are stored locally, and you can navigate to them when you do resolve and read documentation. And they're used for code completion. There is problem with performance, of course. For example, here you see the JavaScript file, like 5,000 lines. Like what to do with that? If you build a tree, then you run code analysis on that tree, like you need to calculate references. The only thing is to try to optimize as much as you can. Like do incremental PSI updates on when you change a method. Don't rebuild all the tree. You don't need to run Lexer on all the files, so you only rebuild the part of it. And of course, we try to utilize multiple cores to make it faster. Sometimes the laptop hits because of that. Yeah. Another problem is framework-specific type inference. For example, in Django, as I said, there are Django models, and you need actually to understand the type of it. So you need to infer types from special functions that they return object of those types. Write some framework-aware logic to resolve that. It's not a big problem. There is another problem, that Python, again, is a dynamic language, and some attributes are added dynamically. Look at this beautiful code inside Django. ORM support. It's actually very cool because it does a lot of magic which you don't know about. You just use Django ORM and it works, but actually it works a lot of things. And one of the core classes there is option class, which is assigned to meta field, and it does a lot of things to link your models. And here, for example, you see that it adds ID field to your model class, and how to provide out completion for ID field. Like here we have ID field in the auto completion. How to provide? The only solution is hard code. It's not possible to analyze this code. It changes a bit with every Django. Not with every, but sometimes it changes. So you have to hard code such logic. But there is another problem. Where you will navigate if you hard code? You just can add, like, the model has ID field in some cases. When you want to resolve it, where to go? Of course, you can hard code the place in the file, but that won't work because in the next version of Django, the lines will change and it won't work. So what we do is we hard code, but we hard code the way like this field is dynamically added. So here is some piece of Java code that says that this ID field is added to the model in this like package and class, and it works because it's more robust. Another problem is reverse dynamic attributes. For example, here you have a post. That's again for Django Girls tutorial. You have post model which has one-to-many relations to user, many-to-one relations to user. And what does Django ORM under the hood? It adds a post set field, but when you want to make completion in the user object, you cannot, like, you don't know is it there or not because it's added from some other model. So it's added in the reversed order. So what you need to do is you need to have a separate type of indexes that are special Django aware indexes that in the beginning go through all models in your code. They are also incremental, and those indexes like store information like, okay, this is Paul's class. It actually modifies user class. and we store for user class that's modified by post model. And so when we ask for the code completion for user object, we go to the index. Do you know about some other reverse fields? So it will take it out of there. And also, of course, we need to have caches. Indexes are not sufficient. Another thing is dynamically evaluated framework configuration. Like it's Django settings, right? People can write anything here. It's Python code. But we cannot execute it because it will be very slow, and actually it's not it affects code inside. So you cannot run Python because it can hang. It will start slowly. So the only one solution is to have a custom evaluator of Python expressions. It might fail for some syntax, but it will never hang, and it's fast. So we use it to fix this problem. And another case, for example, there is a managed Py console, which I forgot to show in the demo, but probably you know about that. It also takes, there are custom commands, and you need actually to introspect somehow user code to get those commands. And we first try to make it statically, like with the evaluation settings Py, but that was not acceptable here because when you don't have right thing for completion, it's okay, but when you don't have your command which you use, you just don't use this tool. So here it should have all the commands you have declared. And that's why here we use Python runtime. And also here we can afford some performance overhead because of that. Another problem which is much harder, which doesn't have solution, is mixed languages. You can have Django tags in JavaScript, and people write something like that. And it's not the worst thing because people sometimes use JavaScript there. You can have Django tags and mustache templates as well. So like 3, and it's crazy to make code insight on that. There is partial solution which we try to apply. For example, when we know that in some places we can expect Django template tags, JavaScript parser still says that it is an error, but then we suppress this error on another level. But there is no general solution how to write parser this way that it will work with some templating language. For HTML it works pretty well, but for JavaScript, for example, you can mess up things. But for HTML as well. Finally, the last one, problem, there are bugs in web frameworks. For example, Pyramid project, it has very diverse project configuration. There are several types of scaffoldings and templates, and some time ago, Pyramid switched to cookie cutter to generate projects. But the problem is that they deprecated the old way to create projects, but they didn't make the proper new way. So cookie cutter templates are not fully implemented. They implemented for basic cases. For some rare cases, they are not implemented. And people start to complain, like, why PyCharm fails? PyCharm doesn't generate Pyramid project well. And in this case, the only solution is to fix it in the IDEA side. So we just, okay, Pyramid doesn't generate project well, so we do that. So I hope that in this short time I could explain what are the difficulties of tool developers. But it's always fun. And the thing I would like to ask you is if you have any problems with PyCharm, just submit issues. We like to solve hard problems. Thank you very much.